Hey, did you know that you can have RealTuners do remote tuning on your standalone ECU-equipped ride? Whether it's a street rod or a pro mod or anything in between, chances are good that we have experience tuning a combo just like yours. Methanol, ethanol, gasoline, or propane. Turbos, centrifugals, screw blowers, nitrous, or naturally aspirated, we have you covered. We work with most popular standalone ECUs and ignition systems. We do base LS tunes on popular standalones like a Holley Terminator X for as little as $200. We also do remote troubleshooting. Do you have a pesky misfire on your drag car that you can't get rid of? 1 hour of our time is all it takes. We offer money-back guarantees, too. Contact us at 402-680-8853 or email scott@realtuners.com. Check out realtuners.com/remote for more information. A little bit of money and an internet connection is all you need to have a professional right there with you. Good evening, everyone, and welcome to RealTuners Radio, episode 102. Tonight we have a couple things planned. First, a brief discussion with John Capizzi of Capizzi Automotive about his recent outing, taking on more of those stock bottom-end LS 8th mile drag records. Then we're going to switch gears and talk with Josh Hamming of Weld Racing, makers of the most popular wheels in drag racing. He heard our show last week and decided he'd like to join us to add some detail to areas we don't normally think about during chassis setup and tuning. And as always, we have our usual panel of hosts. So sit down, strap in, hold on, and get ready. Welcome to episode 102 of RealTuners Radio.
Ring Central.
Hey, lo and behold, it's working. How's everybody doing tonight? Sorry, my mic sounds a little bit crappy because I'm talking in my kitchen over my phone.
Nevertheless, you sound awesome.
Thank you. You just saying that to make me feel better. Because I sat here and tested this fancy microphone for like 7 hours, and it didn't break at all today. 30 seconds before the stupid show, the thing stopped working.
You know why? It's because I logged in.
No, it was working good for 10 minutes while you were on.
Yeah, I think it went sideways when Evans got on. I'm sure there's no correlation.
I don't know. We're gonna switch over to some of his tools, but other than that, everything else has been working good on this new setup. So let's start off with our good buddy, Mr. Jonathan Capizzi, who's always pissing people off. Tell us about your recent outing and the numbers you ran, and also kind of the new combo. The car's a little bit different since we talked to you last time.
Yeah. Well, this is a whole new car now. I bought a car from Curtis Martin, and it's ex-grudge car. It's a 25.2 chassis, which that was kind of on the list of things to do. I was kind of outrunning my cage cert a couple years ago, so had some ideas on what to do with a proper chassis. So came up with this car. Everything's in the right place. So I bought it as a kind of a 3/4 roller, no front suspension, and finished the roller off and put together a methanol fueled LC9 based, junkyard short block. And 417 Motorsports did the high ram 16 injector conversion. It's got a Baker cam in it, and did a little bit of head work, just exhaust porting. And yeah, it finally we have about 33 total passes on the car now. All the new car bugs this year. I broke it bad at LS Fest. It was going fast there, but I had a fuel filter come apart, and the crud, the bonding agent from the end cap on the fuel filter ended up in the injectors.
Oh no.
So I had one whole catastrophic lean and detonated and shoved all the parts out the bottom. So I had an LC9 that was 1, 2, 7, and 8 cylinders intact, and the center 4 were gone. They jettisoned out the bottom of the pan. So came back, whipped another motor together, and that's what's been in the car the last 18 passes. And kind of the magic started happening, 2 weekends ago. I went testing at Dragway 42 in Ohio. They had a radial prep day. So we hauled out there. That was about a 5-hour trip for just daytime testing on a Saturday. Made 5 passes, went, what do we go? 489 off the trailer, pretty soft. 483, leaving on a little low boost. 76, and then a 469, still with only like a 114.60. So pretty soft up front. But we got a lot of good chassis data from that day. So we grabbed everything that we kind of learned from then and brought it to Ohio Valley this past weekend. I was going to run at Turkey Bash, and we went for the test day on Thursday. And off the trailer, the thing went for the sky. It went for the bumper the first 2 passes. So kind of made wholesale changes getting the chassis to stay down. And the 3rd pass, I had taken a little bit of starting line power out of it and added some nose weight. And it went 106, 60 foot, went 295 to the 8th, and went 450 at 155 and change, almost 156. And there's still a bunch of room in the tune-up. There's no heat on the plugs at all. Every time I add a degree of timing, it's still gaining almost 2 miles an hour. And it's losing temperature going down the track. So it's fueled heavy. It's a happy methanol combo right now. And it is
losing temperature. Exhaust gas temperature?
No, coolant temp.
Got it.
That 450 pass, it actually lost 7 degrees from stage to shutdown. So kind of the data that I've gathered, and my buddy TJ at Baker is kind of my tuning sidekick with the methanol stuff, especially because he tunes Adkins' car. And that was sort of the ringer. How is it fueled? Is it fueled heavy? Then you're going to lose some temperature. Is it fueled on the light side? Then you're going to gain or maintain. And my car still has water in it. It has a little Honda size Speed Factory radiator. So it's got probably, it's got half of a normal cooling system. It's got a small Davies Craig pump on it that I have the Holly running when just to maintain temperature. And then just a small fan on that Honda radiator. So we can drive it to the lanes, we can make a pass, get out, stuff the chute on the back of the car, hop back in and drive it back to the pits. And it's 180, 190 degree cylinder head temp at that point. So just really kind of feeling good about the chassis now and just starting to get after the tune-up a little bit. So 29 pounds of boost and pretty fat and lazy yet out the back. It's starting to get happy, but we're not there yet.
In case I missed it, what's done with the cylinder heads on these?
Not a ton really on these. The first set, like the set that was on the motor that I destroyed at LS Fest had better and more port work done. I had spent a little more time on them. After I obliterated that engine, top to bottom, front to back, it was wrecked. It put holes in the steel Moroso pan that was on it at that point. It wrecked the cam. It had, 7 of the lifters were hit to the point the rollers wouldn't move on the axles. It was just destroyed top to bottom. So the heads were junk. Kind of threw the whole thing in the bin and grabbed another core motor. So the engine in it right now is a 250,000 mile core that had 2 of the DOD lifters destroyed, wiped out the cam. And so that's a great motor to start with for this, because all that stuff's going in the trash can anyway.
So when you're talking stock bottom end record.
Yep.
How stock is your stock bottom end?
This engine, as far as what's in the short block, the only parts that I have done anything with, I popped the pistons out, which is a good thing because six of the pistons had stuck rings. You know, real quality starting motor, we'll say. So free the rings up, and I check ring gaps, end gaps. And the second rings in this motor were where I wanted them. The top rings were still too tight, even with 250K. So I filed the factory rings and, throw them back on the pistons and stuff everything back together. The bearings are reused. I haven't even taken the crank out of this motor. So it's if the rod bearings look good, rock and roll. We're running everything. So pop the piston and rod out one at a time. File fit the top ring usually, and then reuse the bearings, reuse the rod bolts. Slap the thing back together.
And obviously you clean the ring grooves on everything.
Yes. Yep. So that gets done, and then it gets a Melling oil pump and a custom pickup and, some windage tray modifications just to try and get some of that oil back to the bottom end. And then, cam lifters. I run a C5R, like a K-Tech timing chain, ARP cam bolts, and actually this engine has, I'm trying to think of whose it is. It's I put a timing or an adjustable timing set on this motor because it was actually 8 degrees advanced. The cam was actually 8 degrees advanced if I installed it dot to dot, like what we always used to do. So this one got an adjustable timing set. The heads are stock valves. I kind of grind the guides shorter just because they have a lot of overhang into the ports. So kind of grind the guides shorter, knife edge some stuff, and then kind of open up the exhaust ports are the biggest thing. Make it a nitrous exhaust port, and they move a ton of air that way.
Yeah, and for everyone just tuning in, this is John Capizzi who just set the stock bottom end LS record. Have I got that right?
Yep.
And how fast in the mile per hour again, please?
It went 155.7. I think was the number.
In the eighth mile.
20. Yes. Yep. The car was 2,516 pounds at that point. There's still some ballast in the car, so it could be lighter, it could be heavier. My other car I can race under 2,800 all steel. So far not that big of a weight difference. I guess it is, but I'm enjoying the methanol stuff at the moment. This engine made 994 wheel horse on 15.4 pounds of boost on my dyno jet. And we were having traction issues at that point with that car. Just trying to find a spot to strap it down. So back of the car was real light at that point. So we gave up at that and went to the track. And
that's just awesome. We've been talking about it all week. We do want to thank you very, very much for coming on and sharing with us, especially because it's stock bottom end, and you know how the internet blows up with stock, what constitutes a stock bottom end or not.
Exactly. Stock or stock-ish.
Yeah. But we've also got Josh Hemming from Weld Racing with us, and we're going to talk about the technology used in current racing wheels and how they can help you to go faster and safer. And we're going to get him on next, if that's okay.
Yep, sounds great.
Thanks for coming on, John. We appreciate it, man. I'm sure we'll be talking to you again in the springtime.
Yeah. I'm going to go quarter with it. We're going to finish it up. So.
Right. Cool. We'll get some more insight into spark plug reading and all those things.
Oh, no.
Lame.
So we've got
I'm just going to start drinking.
Yeah, we've got Josh Hemming on from Weld Racing. How's it going, Josh?
Going good. How are you guys?
Really good. Thank you for being on tonight.
Yeah, no problem. Thanks for having me.
So, what do you want to talk about wheels? Obviously, you're with Weld, and Weld is probably the most recognized racing wheel that there is, especially in the drag racing world. And there have been a lot of, before the show started, we were talking about the classics like the Weld Draglite and the Weld, the Pro Star and the Illumistar. Obviously, things have come quite a way, since those were current wheels. We've, added bead locks. We've added different manufacturing processes. Would you like to just do a short introduction and biography of yourself and tell us a little bit?
Yeah, sure. So I've been drag racing since I was 16. Ended up going to college at UNOH, University of Northwestern Ohio. Got a degree in high performance technology. From there, I did a little bit of nitro funny car racing. Worked on 3 different teams over the span of about 2 years. Worked for Cruz Pedregon, Jack Wyatt, and Del Worsham. That was fun while it lasted. Lots and lots and lots of work and traveling all the time. Found out it wasn't really for me. So left doing that, went to work. I worked at ProCharger for 5 years as a tech. Then 2009 happened, the Great Recession, and they let some people go. But been at Weld for about 2.5 years now, and yeah, that's kind of my background as far as work goes.
So do you want to transition a little bit into talking about the brief history of Weld, where it comes to some of the other companies it is involved with?
Yeah. So Weld was started in 1967 by a man named Greg Weld. He was a sprint car racer that found a need for better wheels, lighter wheels, stuff that he could fix or replace parts of as he was racing his sprint cars. And actually, in 1967, he ran in the Indy 500 also. So he had a vast background in motorsports. And
when you say ran, owner, driver, not all of us on this show and listening were around in 67. No snide remarks, guys. So what was his role in that?
To be honest, I don't know if he was the car owner, but he drove. So he might have been the car owner. I'm not sure. But he was a driver. He finished, I want to say 32nd or something. He got tangled up in a wreck early on in the race, but yeah, it was pretty cool to learn that he had ran in the Indy 500 back then. But a little bit of history, especially a lot of confusion, comes in around 2006 when the company actually filed for bankruptcy. And American Racing came in and bought Weld out of bankruptcy. A lot of people thought that Weld owned American, but it was actually the other way around. At the time of the bankruptcy, Weld had nearly 400 employees. And when American came in and bought us, they basically dismantled the company, stripped it down. Contrary to their name, they didn't manufacture many of their wheels. A lot of it's imported. So they didn't know what to do with a manufacturing facility and how to run it and that kind of thing. So they they basically dismantled the company. It got down to, I think its low point was like 60 employees or something like that. And then 2008 or 2009, somewhere in there, American sold Weld to an investment firm. And ever since then, we've been growing and building and that kind of thing. In early 2017, a couple brothers came in and purchased the company. They're a third generation entrepreneur family. They own lots of businesses here in the States, and they're very dedicated. And we're seeing a lot of changes and a lot of good things to come. So the future is pretty bright for us.
That's awesome. We're watching a lot of pictures roll by. Mark, did you have something you wanted to bring up?
No, I'm good.
Oh, okay. Yeah, so the pictures are great because they're a great way to be kind of reminded of stuff. We were talking right before going on air about what is kind of your halo product, the Delta. You want to talk a little bit about that, where that came from, and then how that technology has affected other products, elsewhere in the line?
Yeah. So the Delta One is our flagship product, I guess you could say. It came about basically the engineers that were with the company at the time, they decided they wanted to reinvent the wheel, per se. And so they came up with a design it's a one-piece wheel. It only comes in 16 by 16, so it's only a big tire application. But what they were able to accomplish was the way the barrel is designed, most of its mass, they tried to keep its mass as central as possible. That way, the further out in the diameter the mass gets and the heavier the wheel gets, the more rotational weight you have. So they designed it to basically get as small as possible, as quick as possible, to where they could keep the center of mass, centered on the hub. And so turns out we were able to, like on a Pro Stock Delta, they are just over 18 pounds as an assembly. That's with the beadlock rings, the hardware, everything. Which a normal conventional three-piece wheel is going to weigh 24, 25 pounds. Doesn't sound like a lot, but with the center of mass so close to the hub, it makes quite a bit of a difference.
How does taking mass out of the outer rim area and moving it toward the hub, what does that feel like in the car, or what changes as a result of that different location of mass in the rotating assembly of the wheel and tire?
Well, the biggest thing, you get more wheel speed. You can get more wheel speed early on in the run, to where if you're on good tracks and stuff like that, it's beneficial in that area, because you don't have to accelerate that mass at the hip. So that's where you're going to see the biggest gains going from a traditional three-piece wheel to the Delta, is in the first 60 to 100 feet. Because you can get better, more wheel speed.
So when we bring that down to a lot more of the wheels that most of our listeners are running, which the predominance for our show are people on radials, but we do have a fair number of people, especially now, running some of the small tire slick classes. We've got a good variety here. one of the questions that always comes up is, how do you decide when you need to go from a conventional wheel? We'll start with radials and we'll cut back over to bias ply and talk about rim screws. But when do you go from just a regular wheel to a single bead lock or a double bead lock?
Yeah, that's kind of one of those things where you don't really need to until you have to, in a way. Basically, if you see tire slippage, mark your wheel and tire. If you see more than, say, half an inch to an inch of movement per pass, then it's time to probably think about doing a bead lock of some sort.
What would be the purpose of having only one bead lock? I have never understood that, because the idea is so that the tire doesn't move on the wheel. Now you're clamping it on one side. I don't quite understand a single bead lock wheel.
Well, in the early days, it was mainly just for looks. You know, people love the look of a beadlock wheel. But and everybody was afraid of like getting the tire out of phase, meaning the inside bead would rotate and the outside bead wouldn't. So then it would be kind of twisted on the wheel. And one thing that we do to combat that is on the inside bead seat, we knurl it. So it helps hold on to the inside bead. Other reasons why you would have to do a single bead lock is for brake clearance. A lot of streetcar stuff, they still run a larger brake. Even these quote unquote 15-inch brake conversions or small brake conversions that they do on the late model cars, like, you know, Camaros and Mustangs and stuff like that, they're still not small enough to fit a traditional race wheel like our Alumistar and V series and stuff like that. Whereas you have to go to one of our street strip wheels like the RTS, the S71 is the most popular, and those are only offered in a single bead lock for that reason, for brake clearance.
We have a listener question. Mike Prolix, I think is how you say that, wants to know if there's any negative performance effects with running a lot of offset on a wide wheel with a lot of power. For example, 3.5-inch backspace on a 12-inch wide wheel versus a 6-inch backspace on the same 12-inch wide wheel.
Not necessarily. We haven't seen adverse effects to that. In fact, and that's as far as the wheel assembly goes. Obviously, kind of like the guys last week from TRZ mentioned, you know, if you're building a car, you almost want to start with your wheel and tire setup and then build the rear end and tubs and all that kind of stuff around what you plan on running. That way you can narrow the rear end as far as possible to get as much weight out of that and stuff like that. And there's a slight, the less backspace you run on a wheel, there's a slight change in weight. It will lower the weight just a little bit. Not a ton, maybe going from a 7-inch backspace wheel to a 3-inch backspace wheel, you might lose a half a pound. But in some applications, guys are counting those half a pound, so it makes a difference in the end.
But the point being, there's no negatives associated with that. So if people are looking at having to narrow a rear end and do all those other things to plan around what their suspension components and where everything's going to be and lay all that out, there's good reason to follow what you just said and reinforcing what Mike and Todd said last week about narrower housing, shorter axles, all goodness on that. You guys are right, and no negatives associated with it.
Yeah, not Not that we found to this point.
We even have one listener that says they run a 1-inch backspace on a 15-inch wide wheel at nearly 3,500 horsepower with a 315 tire on the car.
Mm-hmm.
I don't know if I've ever seen a wheel with only 1 inch of backspace.
Yeah, they're out there. And that kind of leads me into something I can finally kind of talk about. We've never offered a 1-inch backspace wheel, but it's coming. Everybody's probably seen the Alpha wheel. That was it was made to look like the Delta, but with it being a 15-inch wheel, we had to make some sacrifices. We couldn't make it a true one-piece wheel, just because of all the different widths and backspaces available in a 15-inch combination. It's just not feasible. We'd have to have, 100 forgings, and it just wasn't. It's not economical. So what we did is we made a traditional 3-piece wheel that looked like it was a 1-piece wheel and looked like the Delta, the hub design and everything, with it being hubless. And from that, we are developing what we're going to call the Alpha Pro. And it is basically intended for these radio versus the world guys and maybe even like LDR cars and stuff like that, where they need a heavier duty wheel, but still want the ultimate in weight savings and stuff like that. So the Alpha Pro is going to be available in a 1-inch backspace, and it's going to be 15.3 certified. So we're still working on it. It did just pass certification, so it is, technically 15.3 certified now, and we're just working on finalizing the beadlock portion of the wheel, and we hope to debut it at PRI.
Sweet.
I think sometimes people get confused about SFI certifications versus NHRA rules and all of that. Can you touch a little bit on what different types of wheels are built to reach certain certifications? Because we've all seen guys, especially on things like Drag Week, where they're running, quote, race-only wheels, and they hit a pothole and they knock the center out of the wheel, or other things happen. Could you spend a few minutes on what wheel selection looks like for the pure race car? So Jay Blanchard was talking about Atkins Camaro with that 1-inch backspace, 15-inch wide wheel running a 315 radial. Not everybody's quite at that point. So what are the various SFI levels, and what should people be thinking about when they look at purchasing a wheel with a car they're actually going to drive versus only roll it off the trailer?
Yeah. So SFI certifications are, it start out, wheels are certified, and they've got 4 different levels per se, and they all start with a 15. So it's 15.1, 2, 3, 4. And they only apply to quote unquote race wheels, where like a 15.1 is just your typical 3-piece wheel. And let me back up. So SFI does all the testing and all of the they hold the basically they make the rules. Okay, it's got to do this and this and this and this, pass these qualifications, and then it's good to use in certain applications. The NHRA then takes that spec and applies it to their rules. So and I don't necessarily agree with the way NHRA does it. I think they're a little lax right now on the wheel certification requirements, because in the NHRA rule book, cars aren't even required to have a 15.1 wheel until they go 200 mile an hour in a quarter. And then there's certain classes that it just states they have to run it, like top dragster, top sportsman, pro stock, those, and then going on up the ladder from there. So technically, a lot of these street cars and stuff, they don't technically have to have a certification because they're not going over 200 miles a quarter. But in my eyes, a 15-1 wheel should be used pretty much by anybody that's actively racing the car, not necessarily driving it on the street. Just need to pay attention to that kind of stuff. And this is just rear wheels. We're talking as a 15-1 certification. When we go into front wheels, they're all a 15-2 certification. They have certain requirements for, they do load testing on them, both like a kind of a road force type testing, and then they also do a little bit of a lateral load testing on them. And once they pass that, then obviously they'll certify a wheel to be 15-2.
So
like they'll put so many pounds of force laterally against the wheel that's mounted, and they're looking for the center knot to change or bend or break. Is that right?
Right. Yeah, they'll mount the wheel now, and that's another thing. The 15-2 certification really only applies to a spindle mount wheel. Lug mount wheels don't really get tested like this, but yeah, what they do is they'll mount the wheel on a spindle, and then they'll take that wheel, they'll spin it, and then they'll move that spindle side to side and put pressure on the center on the hub part of the wheel, and try to break it. And I want to say the 15-2 spec says it's got to withstand 2,000 pounds of lateral force over, I forget how many revolutions. So it's spinning the wheel and trying to break the center out of it with 1,000 pounds of force, or 2,000 pounds. So
we have a couple of listener questions I'd like to catch up with if we could. Jay Albers wants to go back to the tire slippage question. At a 1/2 to 1 inch of slippage per pass, does it matter or not matter if you balance the tire and wheel package? I always thought that an out of balance rear tire could upset the chassis at the top end of the racetrack.
Yeah, it probably could. And there's a lot of debate on balancing race wheels and tires. Personally, on my own cars, I've never done it. Now, a lot of people will swear by it, that it's got to be done, and they feel a difference and this and that. And I mean, honestly, on the funny cars, going 300 mile an hour, we did balance those, and the drivers could tell when something was out of balance. But yeah, if a tire's slipping and you've got the wheel and tire balanced, then yeah, it will throw the balance off, and could cause problems at the top end of the track.
We have another listener that wants to go back to the single bead lock discussion. If you have that phasing issue with the inside bead moving while the outside doesn't, how does that issue manifest itself as the car goes down the track?
It would probably be kind of like a balance issue where the tread of the tire, or the wouldn't be flat anymore, because it would have probably a little bit of a ripple in it where the beads weren't in sync. So I would imagine it would be either a traction issue or a balance issue, or it would have the car would develop a shake.
Does
because
that single versus double change any when we talk about radial construction versus bias ply construction, traditional slicks?
the bead lock itself doesn't change. Um, the the old method of screwing a tire to a wheel does change. The tire manufacturers don't want to see screws in a radial tire. I would imagine that has to do with the radial part of the tire, that with it being with it having cords in it. But the bead lock itself doesn't change. We have two different bead lock rings on our 15-inch diameter stuff. Once back in, when we first started doing bead lock stuff, the bead bundle on the tire is typically, let's say it's 700 thousandths thick. All the tire manufacturers use, let's say it's 700 thousandths, except Mickey Thompson. Mickey Thompson always used a thinner bead bundle, which was, say, around 600 thousandths. So what we ended up doing, instead of designing one ring that would flex or do this and that to try to accommodate all tires, we come up with what we call the MT ring, because it was meant for Mickey Thompson tires that have the thinner bead bundle. So we try to get 100 to 125 thousandths worth of crush on the tire to try to keep it in place. And so that we had to make that adjustment, that the MT ring is approximately 100 thousandths narrower than what we call our conventional ring. So the naming of the bead lock is, in a way, a little misleading now, because Mickey Thompson's not the only one that keeps changing their bead bundle sizes. So pretty much any radial tire, we're going to suggest running what we call the MT ring. It doesn't matter whose radial tire it is. It could be a Hoosier, it could be a Goodyear, whatever. We're going to put them on the MT ring because they typically use a thinner bead bundle. Now we've got some, and then any big tire car, say any wheel 14 inches wide and bigger, running a slick that's 1432 or bigger, we're going to recommend our standard ring to run that. But as tire technology is changing, they keep changing the bead bundle thickness, so it's kind of a good idea to try to find out from either the tire manufacturer, or if you've got a set of tires already that you plan on running, just mic the bead bundle, tell us what it is, and then we'll get you the correct ring. And it's just the bolt-on ring that changes. So if you switch between tires, you don't necessarily have to have different wheels for it. You can just change the bolt-on ring to accommodate that.
So if I'm looking to order a new set of, say, 15 by 12s, is there a part number difference on a Summit or a Jags or a 417 Motorsports or LJMS or wherever I'm buying my wheels, where I can specify so that I know which bead lock ring I'm getting? Is there a part number difference, a suffix or something, or? And can I get that data from the tire manufacturer if I don't happen to have the set of tires in my hand, so I can know what that is? Or do I have to wait until I have the tires in hand and I actually mic them myself?
The tire manufacturers are getting better at having that data. They didn't always have it before. I've made several calls to different tire manufacturers, and they're like, well, we'll have to get that for you and call you back. So they're getting better at it. I wish they all had that data readily available so that we wouldn't have to wait for it. But yes, the bead lock rings do have, there's The part number does change. Like the end of the part number on a Mickey Thompson or an MT ring is going to be like MB for Mickey Black or MP for Mickey Polished. But the thing is pretty much any wheel less than 14 inches wide, it's going to automatically get the Mickey ring, the MT ring. Just because any small tire, whether it's a slick or a radial, and all radials are going to use that ring. So that's just kind of a standard, basically 13 inches and lower, it's going to get an M ring, MT ring from us. So there really isn't an option until you get to the larger sizes.
And I don't know if we touched on, did we actually describe how a bead lock works?
Yeah, that's a good question. A lot of people don't understand how it works. So basically, it's just a clamp on the bead bundle of the tire. When you put it on, there's on the wheel itself, there's a ring that's welded to the wheel. It's got bolt holes in it and all that kind of stuff. You put the bead of the tire on top of that, and there's a little register there where the knurling is and stuff. And then you bolt the outer ring on, and it just basically clamps the bead of the tire. One thing, it makes it mounting tires and dismounting tires really easy. You can do it yourself at the racetrack if need to. There comes some complications when you have a wheel with large backspaces. Basically, with our race stuff, any wheel, 6-inch backspace is the maximum we can do for a double beadlock wheel. And a lot of people don't understand why. I'll kind of try to describe. It all has to do with basically any more than 7 inches or any more than 6 inches of backspace, you won't be able to get a tire on it. And that reason being is it has to do with the drop center in the wheel and the rear shell. The rear shell, the front and the rear shell are they're shaped different. The front shell that you see on the outside of the car, it basically gets bigger gradually to where the bead seat of the wheel is, or the tire is. On the rear shell, because of brake clearance, you got to put a brake rotor and caliper in there, or a brake drum. It's got to get large very quickly, and then it basically goes straight back. So what happens is as that rear shell gets bigger, as you increase backspace, it limits the you could say that the amount of stretch or the amount of give that the tire is going to allow you to get that bead up and over the welded on beadlock ring. And because the tire, the inside diameter of the tire is it's 14 3/4 inches. So it's only got so much room. And when that rear shell gets so big, you can't physically get a tire on. So it's hard to visualize. A lot of people don't get it, but trust me, if you try to put a beadlock on a 7-inch or a tire on a double beadlock 7-inch backspace wheel, good luck.
You end up needing to use a tire machine at a tire store. Speaking as someone who has some 6-inch backspacing wheels, that gets interesting. Because everybody said, oh yeah, they go on, it's no problem. And it's like, man, I've seen 3 guys wrestling with one to do that when there was more backspacing. And a lot of that was driven by having a stock with rear end. So people are trying to get, 275 under a stock width 8.8 rear axle or whatever it is. And they're trying to run that wider wheel you run into that backspacing. That was actually very informative, because I was about to say, hey, wait a minute, on this easy thing.
Well, beadlocks are usually pretty easy to do, but like he said,
yeah, the more backspace you get, the harder it is to do. Because I mounted a set of 12-inch wide alphas for my car the other day, or a few weeks ago, and I wrestled with it. And I'm like, I have 10-inch wide V series, and they're easy to do, but the backspace is different, and the alpha had a lot more backspace, and yeah, it was way more difficult with the same tire.
We have a listener on.
Say that. Go ahead, Mark.
We have a listener on Mixler. Supercar wants to know: do you suggest dynamically balancing a Weld wheel with a drag radial?
Yeah, there's no reason why you couldn't do that. To be honest, a lot of people just bubble balance. A lot of people have an old bubble balancer that they keep in the trailer. They do it at the track, and they'll bubble balance, and that's what we used on the funny cars most of the time.
I'll say that I've dynamically balanced up to 1432s. 1432s were bias ply, but I've done drag radials. I've done it with even the older style Weld wheels with the loose center. And as long as you clamp it so that the center doesn't move around, I've dynamic balanced everything. And the people that I've done it for have all said that the cars are glass smooth at the top end of the track, even on a bias ply where they say you shouldn't do that. So that's, whatever.
Yeah, it's interesting, Mark. I've always wanted to balance tires with wheels as well. When you get tires, you're at the track, and like you go to the big Mickey trailer, they're bubble balancing everything. So, it's like, I guess horses for courses, but I kind of, especially with the radials, I like it with the dynamic. So
I've spun up the wheels that were done on the Mickey balancer at the track and redone them on a good machine. And that was actually on Mike Head's car, and he noticed a difference in at the top end. I mean, it was like night and day. He said once I did it. So, if you're doing it with good equipment and kind of understand how balancing works, I don't see a problem with doing it.
Mm-hmm.
We touched on rim screws a little bit ago on the bias ply side, and yes, every radial manufacturer says no on rim screws with radials, partly because of the
Some people do it though.
I know, but there's the cord, the core structure wraps around a wire that's in the bead, and it's like, yeah, you're not getting much of a screw in it. So anyway, but on the rim screw thing, is there an optimum pattern or stuff that you guys recommend for your wheels?
Our wheels are a little unique on our non-beadlock wheels. The outer lip, we double roll. That gives it more strength on the bead seat and the outer portion of the lip of the wheel. So what happens there is there's not your typical rim screw. The head of it is not going to sit flat on the lip of the wheel. So with our stuff, you kind of got to go at a 45-degree angle through the lip of the wheel into the bead of the tire. But as far as like quantity and stuff like that, on our website we've got a diagram or kind of a listing. I'm not exactly sure what it says anymore. It's been a while since I've looked at it, but most guys can get away with 8 to 12 per side screws in the tire. I've seen as much as 16 per side, trying to hold the tire. That's probably for a big tire car that's high horsepower. But I mean, I myself don't see any problem with it. It's just it doesn't look all that good, and it's kind of old technology, but it's effective, so I can't fault anybody for doing it.
Josh Sexton wants to know, how would a single bead lock perform compared to a double bead lock?
Granted, if the tire doesn't slip, a single bead lock is actually going to perform a little bit better than a double bead lock, meaning just by the weight factor of the wheel. Typically, a bead lock setup per side is going to add 2.5 pounds to the wheel. So on a double bead lock, you're going to be adding, about 5 pounds of weight. So just for that factor, it'll, a lot of people don't want that weight. And that's about all that's going to change anything as far as performance wise.
So on this weight question, this is one of those things where every season, people are beginning to think about, some still have season left. Some people are wrapping it up and thinking about getting ready for next season. And always on the list is buy lighter weight stuff. And so one of the big questions that always comes up is, if I can take 3 pounds a side out of my front wheels and tire combination, or I can do that, what am I going to get in terms of ET improvement? Have you guys done any real testing on that to see what actually happens if you had a car that was sufficiently repeatable and you could really test that kind of thing?
Well, Bill, do you remember what happened when NHRA Pro Stock was forced to run bead locks and they all complained about the weight and then they went faster?
Yeah.
Actually, I don't, but that's a very interesting point. So what was the theory? I understand the theory why they'd complain.
Oh, it was a big deal because the NHRA was trying to get them to run bead locks, and I wasn't on a team or anything at the time, but I remember they made a big stink about it, and I believe Warren had started running them first, and he went faster, and then pretty soon they were all running them, and they discovered that because they were controlling the tire better, that even though it was a little bit heavier, they were controlling the tires so much better, they were faster. Their 60 foots improved, if I recall. I mean, this was a number of years ago, but that's my memory of it. Josh, do you remember that?
I do remember the stink of it. Yeah, they didn't want the weight and that kind of thing, but I think you're right. The control of the tire and the bead lock itself, a lot of people say it stiffens up the sidewall, and it probably does to some degree. But you got to remember that bead lock ring is only contacting maybe 1/2 inch of the sidewall itself. Most of it is clamping on the bead bundle. So that's not really anything to do with the sidewall of the tire. So there may be a little bit of truth to that on stiffening the sidewall, but I think it's just, the control of how the tire reacts on the wheel. That kind of goes to, when we debuted the Delta, we offer it for both, Pro Stock, Pro Mod, and Top Fuel. But the Top Fuel guys, up until last year, didn't want to run the Delta, even though it's a lighter and safer wheel. Reason being, well, they were kind of, in a way, they were scared of it because when they tried it way back in 2012 when we debuted the wheel, they couldn't get it to work, and that was because the air volume in the tire is a lot more because the barrel of the wheel is so much smaller. There's more air in that setup. So they found out that they had to run more air pressure and do things differently with the tune-up on the car to make it work. And, for the longest time, they couldn't figure it out. But now, steadily, teams are starting to switch over because they kind of know what to do now. Yeah, Pro Stock, there for the longest time, every car in the class had deltas on it. So they were able to get it to work for them a lot easier. And that's probably the thing, is that it controls the tire so much better.
We want to get to Scott has a slideshow of the manufacturing process, and he'd like to lead into that. However, we've got a few more listener questions to get through, and then before we start that, how's that sound?
Sound good.
Cameron Thorpe wants to know if there's any information on Weld's K-code knurling option. Read about it somewhere, but he can't find any information on it.
It's a little known secret that we've got. Yeah, basically, knurling of the bead seat is an option on any of our race wheels and RTS wheels. We don't do it on the ProStar and Dragonite and those things, but what it is we can take a non-beadlock wheel and knurl the bead seats, and it is very effective on keeping the tire in place for a non-beadlock application. A lot of guys are starting to do that, especially real weight conscious guys like, sportsman racers in NHRA, like stock and super stock and stuff like that, where they're conscious of every ounce that's on the car. A lot of those guys are going to it. Basically, it's a $100 upgrade when you order the wheels, and we'll knurl the bead seats on it, and it's basically you just add a K to the end of the part number, and you'll get a knurled bead seat.
For knurl, does it remove any weight?
Knurling does not remove weight.
I know, Mark. I'm just having fun. Well, theoretically, anyway.
Today, I pissed him off earlier.
How do you? The other question we had for you is, how do you properly torque a beadlock ring?
Well, it's a lot like just torquing your lug studs. Crisscross pattern. Take a couple, 2 or 3 steps. The way I do it is I'll run all the bolts down until they're touching the beadlock all the way around, and then I'll go in and actually tighten them in like 2 steps. 18 foot-pounds is what we suggest. Some people say 18 to 22, but torque them, heat cycle the tires, whether it be a burnout, a pass, or a 10-mile drive, whatever. Come back and retorque them just to double check everything once everything gets kind of worked in and seated, and then usually after that they're fine. Check them every once in a while after that, but yeah, it's fairly straightforward.
So is it not appropriate to do 2 Dugga-Duggas on a small Makita drill driver?
Not really, but I'll say I've been known to do that myself, so I can't really fault anybody for doing it.
There you go. I love it.
We've got a couple of quick questions here before we get going on the construction, but Kevin Bolton wants to know, besides balance, how much of a problem does the tire moving actually cause?
Basically, it's going to be more in like consistency and in your short times on the track. If the tire moves, a little bit one pass, but then it doesn't move as much, or maybe it moves more the next pass, it's going to affect your consistency. Also, if one tire on one side of the car is moving more than the tire on the other side of the car, it could cause quote unquote drivability problems. It could want to steer you one way or another on the hit. So that's something that it's going to affect.
Okay, and last question.
Go ahead, Mark.
Last question before we go into the slideshow. Chief and Parker wants to know if knurling could replace the need for rim screws.
Yeah, absolutely. We found it's very effective. not every application it works. I mean, a real heavy car that it's got a lot of power leaves leaves the line hard. It may not work as well as a lower powered car and that's lighter, and it's really hard to put a number on it. So but yeah, it would definitely replace rim screws for the right application.
So, Mark, I've got a tangential question to that real quick, and then we'll go into the manufacturing thing. A lot of people, if you post on the internet, hey, my wheels are moving or tires are moving on the wheel, people will come back and say, oh, I use high tack or something like that. Is that something you guys agree with, don't agree with, don't care?
Doesn't really bother us. I mean, I know friends of mine have done it successfully, so I don't see anything wrong with that. So, yeah.
All right, well, let's make chips.
Scott's got a slideshow that you prepared that goes through the manufacturing process, and I don't know if you can see the slideshow up on Facebook, but you're welcome to comment as the slides go through.
Yep, I'm switching the slides. If you just want to tell me, I started with the first one here.
So yeah, here comes the slides, and we've got a couple of raw rings. It looks like, or the word escapes me.
Yeah, beadlock rings basically. So our beadlock rings are forged. Every part of our wheel is forged. So we get our forgings from our supplier already. Basically, they forge it in a log, and then they slice it up into smaller pieces, and then we'll go and then final machine it, like you'll see there on the left. So that's basically how our beadlock rings are made. If you want to go to the next slide, Scott.
Yep, I'm on the next one. Just remember we're 30 seconds ahead of what you're seeing on the stream.
So I got to ask this question. When you say a log, do you mean that comes as a cylinder and you take those slices out of it? Or did it start out as a solid piece of billet and you guys had to cut the middle and the edges to get to your pre-machining size? I'm sorry.
No, you're fine. It does come to us in a log. Actually, the forge plant actually slices it for us, but so we get it as you saw it on the pallet there. But yeah, it's a cylinder as it comes out of the forge press. So it allows us to basically it aligns the grain structure in the ring and then like all the other parts too by forging it, but then it also helps us with scrap. We have very little scrap because a lot of our parts are going to be very close to the final size.
So the next picture up showed what would appear to probably be centers. Laying also on a pallet.
Yeah, those are what looks like RTS centers. Basically, that's what we call a lathe form. The raw forging comes to us, and then we will put it in the lathe and cut it down and shape it like you see there. And then they go off to polish. Pretty much all of our parts get polished. Whether they're going to be final polish or they're going to be anodized black. So we polish it. We've got our own in-house polish department. There's 8 or 10 guys in there that's all they do all day long is polish parts. So that's a lathe form there. It's in our CNC department that they're going to cut the design in it, basically. From that stage. So,
What's the theory of doing the polish on everything for the centers? Is it just it's easier just to do everything the same way as opposed to having multiple machining and finishing processes, or is there a benefit to doing that step, even if it's going to be black?
there's definitely a benefit. Anodizing by nature doesn't really have a sheen. So if you don't polish a part before you anodize it, it's going to be basically matte. By polishing the part and then anodizing it, it gives it that shine. It gives it that, it basically shines it up because anodizing is somewhat translucent. So you see the shine through the anodizing. And that's what that's what makes them shine. So
Now we're seeing some of the deltas. Here we can see one that looks like it's been fully machined, waiting for a bead lock, and other ones that are in a semi-finished form.
So basically, they're what we call the backbone of the wheel. Basically, a delta is only made up of a handful of parts. Like you see there, the backbone, the two beadlock rings, and the hardware. So at that stage, it looks like they've been to pre-polish. What they'll do is they'll go in and they'll cut the scallops in the beadlock ring itself, or in the beadlock portion of the backbone, and then they'll go off to polish again, just to get it touched up and that kind of thing. And then they'll go off to basically boxing. They'll also cut the bolt pattern and the style, the design in the actual center of the wheel from that stage.
On the bead locks themselves, different brands sort of tout different aspects of it. You just said something interesting when you said that even your bead lock rings are forged. Beyond the structural benefits of the forging, are there design issues with the bead locks that make yours different from other wheels?
Not necessarily. On other manufacturers that they use basically billet plate to cut their bead locks out on. Obviously, there's a lot more waste there, wasted material, and they're not quite as strong, so they might flex a little bit more. But other than that, there's no real like design differences or challenges or anything like that with them.
So we're seeing a raw delta forging on screen right now.
Yeah, so this is how we get our forgings from the forging supplier in California. And that piece right there weighs about 138 pounds.
Wow.
Yeah, 138 pounds.
Wow.
That wheel, and what happens there is we have that one forging for all of our variations of the Delta wheel. We offer it, in 3 different versions, basically the Pro Stock, Pro Mod, and then the Top Fuel. But they're also offered in 2 different backspaces, a 4-inch and 5-inch backspace. So we can accommodate all of those variances with that one forging. Kept the cost as low as possible. Getting forgings designed and built, the tooling and stuff for them is extremely expensive. So that's the best way we could come up with, the Delta platform. But that piece right there at 138 pounds, when we get done with it, a Pro Stock version weighs 15 pounds. Then you add the beadlock rings and the hardware, and the final assembled wheel weighs just over 18 pounds.
Man, you guys are making a lot of chips.
In some cases, yes.
Yeah, that's
I'm stupid about this. Does this go on a lathe? They just start turning this thing to its final dimensions, or what?
Yeah, it gets put in a vertical lathe, and yeah, we just start going to town on it.
Gotcha.
Wow.
Wow.
So you guys don't really have to use fancy 5-axis CNCs or anything like this. You can do this all on a vertical lathe and then some sort of a mill probably for doing the bores for the studs and all that sort of thing.
Yeah, it's a little bit different. You know, I said earlier I worked at ProCharger, and they've got these, you know, big fancy, you know, 5-axis and, you know, all this stuff where the part moves all the time and this and that for their impellers and stuff. But here, yeah, it's fairly basic lathes and mills and stuff like that. We've got approximately 30 CNC machines in our CNC department that run. We've got a full first shift and then a partial second shift that runs our CNC equipment. So,
I apologize. I'm going to ask you a slightly political question, but I'm curious to see how this affected you. I'm involved in manufacturing as well, and we saw a hit from this. But when the aluminum tariffs were introduced, did that impact you guys particularly?
this latest go round, no, because none of our stuff is offshore. But the first round did affect us a little bit because we don't have much choice in this, but the raw material that goes into the forging does come from overseas. So it affected our forging supplier and then obviously trickled down to us. But this latest round was finished goods from China that we don't have any finished goods, so they come from there. So yeah, it didn't affect us.
Well, there's a feather in your cap for everybody who's listening. One of the this is not a question on the Delta wheel, and we're seeing a beautiful picture of a whole bunch of them on pallet right here. Do you guys have recommendations, or do you talk to people about when they should be going from conventional studs? You know, a lot of cars now have half 20. GM for a long time were the little 7/16ths. At what point do you think people should be looking at going from a traditional half 20 stud to 5/8 drive studs? And is there a particular brand or approach of the way the studs are constructed that you guys prefer?
As far as we don't really have a specific brand, but we prefer one that's got a shoulder on it, one that's not threaded all the way, because the wheel itself, all of our race wheels are designed to accept a 5/8 stud. So they've got, you know, the stud diameter is like 702 thousandths, and most 5/8 studs are going to have an 11/16 shoulder, so it's going to be, you know, 685 or whatnot. So it's basically a perfect fit. So, and that's going on the shoulder of the stud. As far as when to go to a 5/8 stud, we don't really have a number for it. I know myself, I've got a 4th gen Camaro, but it had 12 millimeter studs in it originally, and even the ARPs that I had in it, they were starting to bend slightly, and I want to say I was doing like 140, 150, 60 foots. So at somewhere in that range, I would recommend going to a 5/8 stud.
That pallet of wheels, I thought those were turbo inlet bells for some of Little John's new big turbos.
Yeah, so there you can really see how the Delta is necked down to the center of the wheel. Obviously, the top portion there looks like a shot glass or a shaker or whatnot, or a jigger, whatever. But and then the backside, it flares out real big to go around the brakes. So that's a good illustration of that.
Yeah, I see that you guys need to have miniature versions of these as tchotchkes in the booth at SEMA and PRI for us all to come pick up, because I think those would be awesome.
That's not a bad idea.
Hey, I had a good idea. Write this down. Another little question on this is, I wrote a story for CarCraft last year, and this was about proper torque specs for wheels. And the number one thing that we see with problems, and Mark brought this up on our pre-show conversation with wheel failures, is because people inadequately torque the nut onto the stud. Do you guys provide instructions, or do you have a general direction for people on what they really ought to be doing in terms of torque spec for the different sizes of studs?
Yeah, we basically just, like you said, it's all dependent on the stud itself. The wheel itself doesn't really make a difference in what you need to torque it to. So I want to say on top of my head here, a half-inch stud, we're going to recommend somewhere around 85 foot-pounds, and that goes with a 12 millimeter also.
Half-inch is usually 120.
No, I take that back. 7/16 is usually about 85. Then we recommend 100 for 12 millimeter / half-inch, and then 5/8 go to 140.
I'm going to be with Mark on this. We recommended 120 on the half-inch. We being a brake manufacturer, I'll just leave it at that.
Sure.
Our stuff, but yeah, and actually higher than that on the 5/8 stuff. So it's just a reminder to people that if it's the clamp load that holds the wheel in place, not the stiffness of the stud. So the first thing to look at if you're windmilling the studs or seeing other stuff is make sure you're tightening them adequately.
Mm-hmm.
We're seeing a picture now.
I want to touch back
Mark.
on a second, Bill. We had, when in our pre-show discussion, I had mentioned that there was a friend of mine that had a wheel failure, and we were just saying that a lot of things can cause a wheel failure. And one of the things I said that could cause a wheel failure was an improperly tightened wheel. I didn't say that's what caused that particular wheel failure. I posted a picture of that wheel in the on Scott's Facebook page when we were talking about having Josh Hamming on, and Josh saw the picture with the wheel with the center torn out of it. What else have you seen that causes wheel failures like that, Josh?
Well, mostly with that style of wheel. Now, that wheel was basically it wasn't forged. It's a billet wheel, billet center that's just cut out of a flat piece of plate with a design in it. With ours, you saw you see the forgings there. That like the forging there. That's a front wheel. That's a spindle mount front wheel forging that you're seeing now. It's more 3D. It's curved. It's not just a flat piece of aluminum. And then with it being forged, it gives it that additional strength too. But so for one, it takes better lateral loads because it's not a flat piece of aluminum. And so a lot of the failures I've seen have been due to that. Now, we've also seen failures with our wheels. Everybody does. And more often than not, the case with our stuff, especially rear wheels, it's due to age and the amount of use it's had. And a lot of people don't realize this with wheels, but it also has a life cycle. It's a lot like an aluminum connecting rod. It's got a life cycle in your engine. The more you work it, the more it flexes and bends and gets jarred and that kind of thing. It's going to weaken the material over time. So that's the biggest thing that we see with our stuff that fails is it's usually due to being used a lot. And And
So
as far
that raises the obvious question, is used a lot. So I'm at the swap meet and I'm really jonesing for a set of 10 by 12s because I want to stretch my radials a little more than I have been. And I'm like, I'm not quite up for the $987 per double bead lock. So I pick up a set of used 10, 12 by 15s. Anything I can do other than just sort of the usual physical inspection to determine if a wheel I've just bought is going to be safe if I buy a used wheel?
it other than a visual inspection, it's kind of hard. You're going to want to, obviously check for cracks and any kind of stress in the material. That's a big reason why we don't powder coat race wheels. And actually, SFI is not going to allow powder coat wheels going past, like, I think it's 2021. But any wheel that has to be recertified will not be able to be recertified if it's been powder coated. But reason being is you can't see cracks through it. Anodizing, you can, because like I said, it's somewhat translucent to where you can see failures in the material behind it. Obviously you're going to look at the lug holes and stuff like that to see if they're oblong or worn out, stuff like that. But that's kind of about the only thing you can do if you're concerned about buying a used wheel.
The other thing to consider is how much is your car worth, because we all know a wheel braking or an axle braking usually isn't real good for the car.
Right. And yourself, depending on where it happens. So, yeah, it's definitely something to keep in mind. I mean, I'll tell a quick story. I had a customer, I think it was last year, send in his wheel. He had a wheel failure, a rear liner wheel fell, and it was on a Pro Mod car. And I sent it back to us, and we looked at it. First off, we noticed it was not in the greatest shape. I mean, just overall, yes, it was broken, but overall, it was in terrible shape. It looked like it had been around the world and back. Well, come to find out, it kind of had. It was off of one of the original Alanabi Pro Mod cars that had gone over to the Middle East, raced over there, raced over here. That team had a huge budget, so who knows how many hundreds or thousands of runs these wheels had on them. And we could tell that actually real recently it had started to crack and it was continued to be run. So my biggest thing now is inspect your equipment. Make sure, after every race, check everything out. Not only just the wheels, but everything, nut and bolt the car and stuff like that, to where just make sure you know what's going on with your car. Because, a lot of these bigger teams that have crews that work on their cars, the driver or the owner of the car doesn't always, pay attention to a lot of those things. They rely on their crew to do it. In that case, train your crew members to check that kind of stuff out, because it does happen. I mean, it's not, something like that. It's not really the fault of the wheel or the manufacturer. It's just, it was worn out and needed to be replaced, but it failed before that happened. So.
I apologize in advance for the noise in the background. My Rottweilers are deciding to chew each other up.
We've got another listener
go
question.
Ahead, Mark.
Here.
Thank you.
Yeah.
One of the listeners on Mixler wants to know if wheels should be swapped side to side at tire change to stop failures, or is it better to be loaded the same way every time?
I really, that's the first time I've ever been asked that kind of question. I don't.
And of course, we have people that swap tires side to side between events to supposedly help sidewall life. I don't know if you're up on that at all.
Mm-hmm. Sure. Yeah. And some guys will change the direction of the tires too. I don't think it really matters one way or another, because for the most part you're going in a straight line. Now that kind of leads me to like, I'm sure everybody's seen front wheel failures, where a wheel's cracked or even broken, and what we're seeing with that kind of stuff is it's not. A lot of people think it's potholes or doing big wheel stands, which to some extent it will happen, but more and more lately, especially on radial prep tracks, it's the side loads that are being, whether if a car gets out of shape on the track, starts sliding sideways, whether it hits the wall or not, there's still a lot of stress on that wheel sliding sideways, especially on a sticky racetrack, because that tire is not going to slip. And then another thing is turning off the racetrack at the big end, excessive speed. Guys are, well, for one, the cars are getting faster and faster, so they're maybe not be slowing down completely by the turnoff. So they take the turnoff, whip it off of there, and it's putting a lot of stress on that wheel, and also pushing around in the pits or pulling the car if you got to change, get into a tight spot, make a sharp turn, a real tight turn, even at low speeds, with a spool in the back of the car and everything. It's pushing the front of the car all different ways. It's putting a lot of stress on that wheel. So that's just things to keep in mind when you're at the racetrack. People ask me about driving our race wheels on the street. I'm like, I tell them we don't recommend it. There's no warranty on the wheel because of it, but a lot of people do it. So it's just one of the things, if you're going to do it, be mindful of what you're doing and what you're putting that through. So
Scott keeps asking me what the next slide is about, but I don't know what he means by the next slide, because it keeps rotating through rear wheels, front wheels, the one-piece wheel.
We're on the next one on the order. Sorry, go ahead.
I think it's the one where they're hanging on the wall with the smooth, pretty discs where they're hanging on the wall, or maybe they're laying on the ground in the picture sideways. I'm not sure which.
It's probably the picture sideways.
Well, like this one here, the one I'm looking at anyway, is the raw forgings of a front wheel. Basically, that forging there is 40 pounds. And we whittle that down. Our spindle mount front wheels are in the 8-pound range when they're done. So that's kind of just that's how we get it from the forging plant, and then we whittle it down from there. So
I wanted to play something back. I thought I heard you say earlier about that all of your race wheels are drilled for 5/8, meaning if you're running something other than drive studs, and again, my apologies for the noise, you're meaning that you're running some kind of a mag shank lug as opposed to a taper seat. Do you guys have any opinions on taper seat versus mag shank, or do you care?
Yeah, I do. Mag shank is actually the better way to go in a high horsepower application. You're driving the wheel off the side of the lug nut and not relying on a taper interference fit, like a conventional lug, acorn style lug nut. So they are safer and that kind of thing. So we would prefer to see a shank style lug nut. Now, having said that, our RTS wheels, our street strip, like the S71, are 15-inch versions. Most of them are shank style. There's a few exceptions. A lot of the newer cars, like the S550 Mustang and the 5th and 6th gen Camaro and stuff like that, they have a 14 millimeter stud. And the problem with that is not a whole lot of lug nut manufacturers make a lug nut that's a shank style for a 14 millimeter stud. So to get around that, those 15-inch wheels are typically made with a conical seat. So you'll use a standard conical lug nut. And then all sizes 17, 18, and 20-inch is all conical stuff. So it's more of a street application.
Thank you for that. I just, we were having a sidebar conversation on Facebook, and I appreciate the clarification on that. We've gone through all the pictures. We've gone through all the elements here. As people are looking at all this and trying to digest all this information, when you're trying to pick the right wheel for your race car, what do you want people to do? Do you want them to call your tech line? Do you want them to talk to the guys at Summit? What's the right way for people to get information and make a decision about a wheel purchase?
Well, I mean, the guys at Summit or any one of our dealers, they're going to have a basic understanding. Well, people at Summit and Jegs may have a little bit less of an understanding just because they deal with so many different products. They can't know everything about everything. But so yeah, you can get some information from them. But if you really have a real technical question or something like that, you can always call our tech line. More than likely, you're going to get me if you call our 800 number. We've basically only got 3 people manning phones. One of them is myself. I deal with all street and strip and drag race products, along with some truck. We've got a lady that's actually been with the company over 30 years. She handles some street strip stuff, and she's our circle track expert. Because we do more than just drag race. We still do sprint car wheels and stuff like that. And she's the go-to on that kind of stuff. And then we've got another guy that helps out with street strip, and then he does all the truck stuff. So, but yeah, feel free to give us a call. We'll, we'd be more than happy to help you out.
You guys have a good Facebook presence. Real easy to find Weld Racing.
Yeah, we try to keep up on that. Right now, we've got a big push on our street strip stuff. So a lot of you'll see a lot of Camaros and Mustangs and stuff like that on there, Corvettes. But and then every once in a while you'll see something drag race pop up, and you can, more often than not, that was me that posted that. So
right, of course.
you can kind of tell, because I gotta slide those guys in there every once in a while, give them some love too. So
no, that's cool. I know we all of our racers appreciate the support.
Yeah, we didn't get to talk about truck stuff much, but if you have like a Ram 2500, does it matter whether your tow mirrors are extended or not as to what wheel you get?
At least funny.
Yeah, I'll leave that one alone. I've got my own opinions on that.
Bev Bewley's tuned out. He's like, God damn it.
I was just saying if he was listening. Gosh, I don't have anything else. Josh, thank you.
Oh, here he comes.
Okay.
Oh, I'm listening.
He's been drinking all night.
No, I just been sitting back, and I don't have a 2500. I got a 1-ton, so there. Ha.
Well, we're an hour and 40 into this, so maybe it's probably time to maybe think about wrapping it up.
Yeah,
I got
Josh, you've been extraordinarily generous. So yeah, thank you, Scott.
Apologies for my crappy mic sound tonight. I forgot to talk about Tyson Williams at Garage Built Racing. He's been holding auctions to donate to the Joe Hunt Memorial Fund. Here in the next couple of days, I understand it, the RealTuners submission is coming up. We donated a remote tuning or troubleshooting session. It can be anything from setting up your engine on a Holly or a Fuel Tech or MS3, getting a safe tune on it, or we can do trackside support if you want us to go through data logs and provide you a list of items to monitor each pass. Or if you have a high RPM misfire and need some input on troubleshooting. Anyway, we got you covered. So they're going to auction off a free session with RealTuners over at Garage Built Racing in the next couple of days. Follow them on Facebook. Lots of other cool auctions they have going on there too. All these other companies that were chipping in to help out the Joe Hunt family. So anywho, go check it out. That's all I had for the night. Anyone else?
Josh, once again, thank you so much. Michael Capizzi, I know you were listening in earlier. Thank you so much for getting on tonight. Everybody out there in the RealTuners world, thank you for dialing in. Make sure you submit your questions early, and we'll get the agenda, because we're now officially doing agendas now, up for the next session as soon as we can. And y'all have a great night.
All right, take care, everybody. We'll see you next week.
Thanks for having me, guys.